Welcome to our YouTube channel. Today I am bringing you a short course on microscopy. Before going into the details, I would like to start with the interactions of light and electron beams with the matter. So let's begin with the lecture 1. Before going into the discussion, I would like to pay attention to the electromagnetic spectrum, and you can see that there are various regions in the electromagnetic spectrum. The visible light contains 7 colors with different wavelengths. As you can see, it is ranges between 400 nanometer to 700 nanometer. In microscopy, our interest is visible light. However, there are some cases where X-rays are associated in the microscopy, or facilities using X-rays are attached to microscopic instruments. X-rays have the wavelength between 0.01 to 10 nanometer. When light interacts with the sample, there could be three possibilities. Either it is reflected back to the medium, or absorbed onto the specimen, or transmitted through the specimen if it is transparent or if it is very thin. The transmission could be 100% or some portion of the light. This is the principle. The color of light coming towards our eye is the color see from our eyes. As you can see in this example, the leaf appears green because it absorbs all other lights except green light. So it appears green. In microscopy, we will be using reflected light or transmitted light, such as metallurgical microscope use reflected light and biological microscope use transmitted light. As far as concerned with the electron beams, when it interact with the specimen, it may produce number of different things, such as secondary electrons, backscattered electrons, X-rays, or it might be absorbed onto the surface or transmitted if the specimen is very thin, approximately 150 nanometer. The transmitted light can be scattered elastically or inelastically. Various electrons generated from the specimen can be generated with different depths of the specimens. This figure showing that auger electrons mostly generated from the surface material. Secondary electrons are coming from a little bit deeper, and the backscattered electrons are coming from much deeper from the specimen. The upper portion of the electron beam schematic, such as showing secondary electrons, backscattered electrons, can be used in scanning electron microscopy, and the things below the specimen is used in transmission electron microscopy. I hope you enjoyed this lecture. Please subscribe our channel, like it, and share it with your friends.